Alright, 12. So you have a vertex, but it passes through a point. Okay, so the thing, now if you're taking the SAT, you might be able to get away with just knowing the vertex. Alright, and so the vertex, now I'm going to leave a little space here. Alright, the vertex is 2/3 of your entire equation in vertex form. Because you have an H, and you have your K. Alright, now we're always going to have, let me zoom in a little bit here. Alright, so you're always going to have the square here. Okay, that's a square actually. Alright, but we don't know what the A is. Okay, so in order to find out the A, we need to know the another point so that we know how wide or how tight the actual arms of the vertex are. And so what we do is we have this A here. Okay, now this A is going to go out in front as A. Alright, but what we're going to do is we're going to take that extra point and we're going to plug it into the function to figure out what A must be in order to pass through that point. Okay, if I have it too wide, it won't pass through the point at all. If I have it too skinny, it won't pass it. It's got to be just right. And so we have to figure that out. And so what happens then is that the 4 is the y coordinate, okay, and the x is the 0. Alright, and we still don't know what the A is. I'll go ahead and just make it in black here. Okay. Now what that allows us to do, now don't overthink this. This is a very easy thing to solve because all we got to do to get rid of the parentheses is figure out what 0 minus 2 squared is, and then you're back to pre-algebra because now you just have a two-step equation. Excuse me. So this is going to go back to black there. That's going to be 4. Okay, negative 2 comes as a result of this subtraction. We square it, that's positive 4, so you get a 4a plus 1. Okay. So now we solve this like you would normally do. You would go ahead and subtract 1. That's going to give us 3. Alright, and then you divide by 4. Alright. Okay, so our A is 3/4. I don't care that it's a fraction. Alright. It's totally fine to write it as a fraction. So y equals, going back to the original equation, y equals 3/4 x minus 2 quantity squared plus 1. That is my full equation. Now if we were to type this into Desmos, you will find that putting that 3/4 is necessary for it to pass through 0, 4 perfectly. Okay? We're going to do the same procedure with 13. So again, 2/3 of the equation is just having 1 and 5. Now maybe, if you're taking the SAT, that might be good enough. Maybe you can see you could use the process of elimination, actually have the answer looking at you right now. But if you're a professional, you want to throw that point in so you get it, your A exactly. Okay. Alright. And even the graphing calculator wouldn't help you with this because it would you would just be guessing and checking, and how are you going to guess the number 3/4? You know, it's just not possible. Alright, so here's our A, and then the 3 goes here. Okay? Okay, so again, don't worry about this. This is not a big deal. We have only one variable. Everything else is an integer, so we can solve this. Negative 1, 3 minus 1 is 2. 2 squared is 4, so now we're back to 4a again. Plus 5. We're going to move the 5 over here to get a negative 6. Okay, we're going to divide by 4, so negative 6 divided by 4 equals a. We're going to reduce that fraction to negative 3 over 2. Alright, so this guy, because it's negative, meant that this guy has to point down in order to pass through this point 3, negative 5. And let's just take a second to think about that too. 1, 5 would be right there. Okay, and if it has to pass through 3, negative 1, okay, you can see right there that in order to pass here, and if that's the vertex, it must point downwards. So that makes sense. Our final answer is negative 3 over 2 with that x minus 1 quantity squared plus 5. Altogether, that's your final answer. Okay, so they're not too involved problems. but you do have to kind of go back to your pre-algebra stuff. All right. So this guy, I'm just going to use this open space. This is kind of a quick one. This is number 14. The graph of the function x squared will be translated 4 units down, 2 units to the right. What is the resultant function? All right, of g of x. Now, g of x. Now, in order to get this right, you actually have to put g of x, because f of x is x squared. That's the parent function. So if they explicitly tell you that you have to use g of x as the label, you must have it in your answer. Okay. Now, they do say that you're going to move 2 units to the right, so we know that that would be x minus 2, quantity squared. And then it also says that you're going to be translating downward negative 4. It doesn't say anything about stretching or compression, and so our A is just going to be a default 1. I can't remember who it was. A couple of you asked. It doesn't say anything about stretching or compression, so what should I do for my A? And I thought that was a really good question. You leave it as just 1 because it's not mentioned. If it's not mentioned, the parent function is just, it's not going to warp. Okay? It's just going to be a rigid transformation. All right. Now, I can't remember if we did 15 or not. Okay. No, we did not do 15. Let's do this last section here. All right, 16. We'll do 16 and 17 in this video. Scoot this upwards. All right, find the vertex and y-intercept, okay, of a quadratic function. Now, y-intercepts are the easiest. They're actually looking at you right now. You can actually find out what those are for both 16 and 17. All right, but let's go ahead and do the vertex first. We'll go in the order in which these are listed. So I'm going to rewrite this here. It's x squared minus 6x plus 15. And so my number in front here is an invisible 1. That's an A. That guy is my B, and that guy is my C. Now, I'm doing this because he is in standard form now. Okay, standard form. I'm no longer, he's not graphable like this. And so what I have to do is I have to resort to actually a piece of the quadratic formula. It is the x equals negative b over 2a. All right, and we talked about this, and actually in calculus class, we derived that. We figured out where that comes from. And so in Algebra 2, you just have to kind of trust that this works. Okay? So you just use it. And so what we do is, in order to find the vertex, you have to use this formula if it's in standard form. Okay? So we just take our labels. We find that this is negative 6. So a negative 6 over 2 times a. All right? Now this is a positive 6 now, so that divided by 2 is going to give us a 3, so x equals 3. Now what that just did is it told us what the x coordinate is of the vertex. Okay? And what it also told us is that it's also the axis of symmetry. So we know that at positive 3, the spine of the quadratic is going to go vertically at x equals 3. Alright, so right now we have 50% of our answer. Okay, we know that that's the x-coordinate. Now to get the y-coordinate, all you got to do is go back to the original function and just plug it in. Okay, now remember, it's very important that you use parentheses because when you square a negative, it's got to be positive. Some of you are still typing negative on the outside like this. Okay, you're doing that in the calculator, and that's going to get wrong. So you got to make sure that you square it, because when you square a negative number, it's got to be positive. All right. I'm getting mad just thinking about it. 3 squared is 9. 9 minus 18 plus 15 is negative 3. I'm getting 6. All right, so there's our vertex. So we'll just label that with a capital V. I know what you're talking about. Everybody else is going to know what you're talking about. And now we just have to get the y-intercept, and the y-intercept is when your x-coordinate is 0. Okay? So here we went through all that time to figure out what the x had to be at the vertex, but for a y-intercept, x is already 0. So we can plug 0 back into the original equation, but it's no need to, because you can see that these guys would definitely be 0, so therefore it's just 15. Okay? So we could actually get a nice graph just based on this information alone, get an idea of where it sits, how it points, where it hits the y-axis, where it might hit the x-axis, and so on and so forth. All right, but that's all. Oh, yeah, we actually use them to graph the function. So, we go 3, 6. Okay, let's pretend that's 3. Okay, that's 6. Let's pretend that that's 6. And then let's pretend that this is 15. All right, so it's going to look just like that. Okay, all right. Okay. I know it's not exactly 15. I'm just trying to move along here. All right, so that looks good. All right, if you had to graph this on the test, your scales would already be ready for you. Okay, 17, the same process. Looks like we've got 4x, y equals 4x squared minus 15x plus 9. Okay, so already I do know the y-intercept. Okay, the y-intercept is right there. He is 0, 9. Okay, but now we need to find out the vertex, so let's go do that. Remember the formula, negative b over 2a, and that'd be negative 15 over 2 times 4. Alright, that's positive 15 over 8. Okay, a little cruel there, because we got to plug that in. And I'm going to double check that just because that's uncommon. Negative b. Let me just make sure I wrote that right. Negative 4x squared minus 15x plus 9. Okay. So, negative b, positive 2 times a, can't, no GCF, 15 over 8. Yeah, that's pretty mean, pretty cruel. So, you gotta figure out what this is. Alright. I'm actually just going to type it as exactly as I see it here. And if you remember, you can get a fraction if you do alpha y equals. Right there, number 1 is a fraction. Okay. I find this helpful when I have to do something like this, where it's kind of relatively larger fractional numbers, and nothing canceled out at all. So this is super rare to see this, but it definitely happens, and definitely happens on the SAT. So when I hit enter here, looks like I get negative 81 over 16. Alright, so what is that as a decimal? Negative 5.06. So either one is absolutely acceptable. So the vertex would be 15 over 8 and negative 81 over 16, or you could say 15 divided by, you know what, let's just make it both decimal. 15 divided by 8 is 1.875, comma, negative 5.0625. Okay, that sounds more like a scientific answer right there. That would be the best way to go. Alright, we'll stop right there.